Welcome to lesson 4.6, which is all about the quadratic formula. So, whenever we have a quadratic that's in standard form, so ax squared plus bx plus c, what we can do is we can use the quadratic formula to solve for it. And this will give us our x-intercept. So, if we can't factor it, then we can use the quadratic formula. Works really well for some trinomials that don't have whole number x-intercepts or whole number solutions. So we'll see a few examples as we go through. The quadratic formula itself is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So all we need to do is take the coefficients here, a, b, and c, and put them into the formula, then solve for x. So the quadratic formula is used to help find the x-intercepts, if there are any, of a quadratic relation. When the quadratic relation is in standard form, we just use a, b, and c in the quadratic formula and solve for x. This will give us the x-intercepts, which are also known as the zeros or roots of the parabola. The quadratic formula, as I showed you up above there, is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Um, the answer that we get here will be the x-intercepts. This can come in really handy for factoring quadratic relations, especially when we can't readily see the two numbers that we need in order to factor it. So if we can't factor it, if we can't see an easy way to factor it, we can use the quadratic formula. So example 1, use the quadratic formula to find the x-intercepts of 2x squared minus 12x plus 12 equals 0. So remember, this is an ax squared plus bx plus c format. So one thing I'm just going to put here, a equals 2, b equals negative 12, and c equals 12. So now I can put that into my quadratic formula. Remember, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So b is minus 12, so minus 12 goes in there, plus or minus the square root of minus 12 squared, minus 4 times 2 times 12, all divided by 2 times 2. So we can simplify this a little bit. Minus 12 is just going to become positive 12. And then that's going to be plus or minus the square root of negative 12 squared is going to be positive 144. And 4 times 2, minus 4 times 2 times 12 is going to be minus 96. So we get the square root of 144 minus 96. And that's all divided by 2 times 2, which is 4. So now we're going to solve what's under our square root and take the square root of that. So 144 minus 96 should give us 48. Let's find the square root of that. It's 6.92. So we'll have 12 plus or minus 6.92 all divided by 4. We have two different operations going on here. And so we need to split it up at this point. We're going to split it up so x equals 12 plus 6.92 divided by 4. And the other equation is going to be x equals 12 minus 6.92 divided by 4. So I'm just going to simplify that. 12 plus 6.92 is going to be 18.92. So we get x equals 18.92 divided by 4. And we also get 12 minus 6.92, which is equal to 5.08. So x equals 5.08 divided by 4. We just divide that, and now what we're going to have is our x-intercepts. So x equals 4.73 and x equals 1.27. And those are our x-intercepts for this question. If we want to verify that, let's just go back up to the formula, 2x squared minus 12x plus 12. And we can go and we can put that right into Desmos. So let me just cancel that here. So the formula again was, let me just go back to it here. 2x squared minus 12x plus 12 equals 0. I'm just going to copy that and paste it right into Desmos. So we do that, and oh my, what's going on here? Oh, haha. That's because it did not like that. Sorry about that, folks. Let's just make that a squared. 2x squared, and we can see now I need to zoom back in on this. All right. So now we get this parabola, which if we look at it, goes a long way down here. But what we're interested in is the intercepts. So we'll just look at the intercepts here. So our first intercept here is we get 1.268 or 1.27 and 0. And over here, 4.73 and 0. And if we go back to what our answers were, we had 1.27 and 4.73. So it works. We've got our x-intercepts. All right, let's do another question here. So example 2, solve x squared minus 6x minus 91 equals 0 using the quadratic formula. So once again, we're going to use our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And once again, we can list a equals 1, b in this case equals negative 6, and c equals negative 91. And we can put that right into our quadratic formula here. So now x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 91, all divided by 2 times 1. So we plugged our numbers in. Now we're just going to solve this. So negative times negative 6 is positive 6. So we get 6 plus or minus the square root of negative 6 squared is 36. And negative 4 times 1 times negative 91 should be 364. So we now have 6 plus or minus the square root of 36 plus 364, all divided by 2. So let's simplify our square root here. 36 plus 364 is going to be 400. When we take the square root of 400, there's some good news here. We get 20. We get a whole number. So now we've got x equals 6 plus or minus 20, all divided by 2. Now we're going to break up our equation, our quadratic formula, into two separate equations. We're going to have 6 plus 20 divided by 2 and 6 minus 20 divided by 2. So 6 plus 20 divided by 2 is going to be 26 over 2. 6 minus 20 is going to be minus 14. So our other equation is x equals minus 14 over 2. Now we're just going to simply divide. 26 divided by 2 will be 13. And negative 14 divided by 2 is going to give us negative 7. And that's our solutions. We won't verify that one with Desmos, but you can if you want. Or you can actually sub in 13 into the original equation, solve for y should equal 0, and you could then sub in minus 7 into the original equation, and once again, see if y equals 0. Example number 3. Now, at this point, I recommend that you pause the video and you try this question on your own. So we've got y equals negative 3x squared minus 6x plus 15. So give it a shot and then restart the video and see how you did. All right, let's just take a look here. Well, oops. Get into that. Let's do A equals negative 3, B equals negative 6, and C equals 15. We're going to put this all into our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So we get minus minus 6 plus or minus the square root of minus 6 squared minus 4 times minus 3 times 15. And all of that's divided by 2 times minus 3. So let's simplify this. Minus minus 6 becomes positive 6, plus or minus the square root of minus 6 squared, which is 36. Minus 4 times minus 3 is positive 12. 12 times 15 should give us 180. So we now have 6 plus or minus the square root of 36 plus 180, all divided by 2 times negative 3, which is negative 6. Now we're going to solve for what's under our square root and square it. So 180 plus 36 is going to be 216. We're going to find the square root of that, and it's approximately 14.7. So now we have x equals 6 plus or minus 14.7 divided by minus 6. Here we're going to split our equation into two separate equations. We're going to have 6 plus 14.7 divided by negative 6, and 6 minus 14.7 divided by negative 6. So 6 plus 14.7 is going to be 20.7. 6 minus 14.7 is going to be minus 8.7. And both of those are going to be divided by negative 6. Notice here we're going to get a negative number because we have a negative 6 in our denominator, but a positive numerator. In this one, both our numerator and our denominator are negative, so we'll actually end up with a positive number. A negative divided by a negative will give us a positive. So our two roots are going to be x equals negative 3.45 and x equals 1.45. Once again, if you want, you can use Desmos and just verify that those are your x-intercepts. All right, so we're going to do one more example using the quadratic formula, and then we're going to talk briefly about the discriminant. So, this is an interesting example. Once again, I encourage you to pause the video, try it on your own, see how you do, and then resume the video to see if you got it correct. So solve 2x squared minus x plus 5 equals 0. So in this one, once again, a is going to be equal to 2. B is equal to negative 1. And C is equal to 5. So we'll put this all into our quadratic formula. And we get minus minus 1 plus or minus the square root of minus 1 squared minus 4 times 2 times 5, all divided by 2 times 2. So we'll start to simplify this. we get 1 plus or minus minus 1 squared is 1. Minus 4 times 2 times 5 is going to be minus 40. And all that's divided by 4. And you might see that we look like we're about to encounter an issue. And I'll explain that issue in a second. So let's solve what's underneath our square root here. 1 minus 40 is going to give us, I put minus 30, I meant to put minus 39. Let's do that. So 1 plus or minus the square root of minus 39 divided by 4. Now, if you were to do the square root of minus 39, so put minus 39 in your calculator and hit the square root button, and your calculator is going to come back and say, hey, we've got an error here. We cannot do this. We cannot find the square root of a negative number unless we get into imaginary numbers, which we were not going to do in this class. So when we get the square root of a negative number, we cannot solve that. So what this actually means is there are no roots or x-intercepts. And I'm going to prove this to you using Desmos. We'll see what happens here when I put the original equation in. Good news is I saved it ahead of time. So I'm just going to close off my other one and reopen this one. And there it is up there. Our minimum point at our vertex here, if we look, is 0.25 and 4.875. It's above the x-axis and opens up. So we can see it never crosses the x-intercept or x-axis. So we don't have any x-intercepts or any roots. So that means there are no roots or x-intercepts for this parabola. So if we get a negative number under our square root, that tells us, hey, we're not going to have any roots or x-intercepts. And that's a perfect segue into discriminants. We're going to briefly look at discriminants here, and then we're done. 4.6. So the discriminant is part of the quadratic equation. It's the part underneath the square root sign. B squared minus 4ac. So that'll go just right underneath our square root in our quadratic equation. So here's what we can do. If we want, we can just calculate out the discriminant, b squared minus 4ac. And if the discriminant is greater than 0, then we have two real roots. And we can see a diagram of that here. A parabola intersects the x-axis in 2 points. If b squared minus 4ac equals 0, so we do that and we get 0, then we have one repeated root. And so that'll be right down on the x-axis at some point. If our discriminant is less than 0, so we get a negative number under our square root, that means we have no real roots, and this parabola never crosses the x-axis. So if we had just done the discriminant with that last question, that's b squared minus 4ac. So just coming up here, b squared gave us 1. Minus 4ac was minus 4 times 2 times 5, which is minus 40. And we ended up, our discriminant in this example was negative 39. So because it was negative, that means there's no roots. All right, one more question here. 4x squared minus 12x plus 8. We want to use the discriminant to find out how many real roots there are in the following quadratic relation. 4x squared minus 12x plus 8. So our discriminant formula, b squared minus 4ac. Remember, a equals 4, b is going to be minus 12, and c will be 8. So we're just going to put that all into our discriminant formula and see what we get. So if we put that in, that is b squared minus 4ac. So b is minus 12, so minus 12 squared, minus 4 times a, which is 4, times c, which is 8. When we work that out, negative 12 squared is positive 144. Minus 4 times 8 will be minus 128. 144 minus 128 will mean that our discriminant is equal to 16. So if we scroll back up here, if our discriminant is positive or greater than 0, we have 2 real roots. So our answer for that one is, since the discriminant is positive, there will be 2 roots. Hope you enjoyed the video. Let me know if you have any questions. Take care.